Okay, hello everyone. So today is lesson 12 and it's on circles, which is more geometry because geometry is fun, right? So um this lesson is actually about like basic vocab first, and then we're gonna talk a lot about like angles and like many interesting angle properties in circles. So first of all, we need to go over vocabulary. So in a circle, there are these like sort of like if you haven't seen them before, you should probably get them down like right now. But basically, what a chord is a chord is like you choose 2 points on a circle, right? And you connect them, and that's a chord. So that's pretty straightforward. And then a secant is basically a line that goes through the circle. So like this is a secant. It goes through the circle. And then a tangent is a line that goes through the circle at exactly one place. So as you can see, this tangent only touches the circle at one place. It doesn't, because for normally, if a line goes through the circle, it's a secant because it touches it at like 2 places, right? It goes in and then it comes back out. But with a tangent, it only touches it once. And then there's things called arcs. And what arcs are they're like these things, like a portion of like the outside of a circle. It's like this would be an arc, and we write this as like arc AC. Oh, that's not a bad arc. It'll have like a curve over it like this. Sorry, that's a bad arc, but like you get what I mean, right? So this would be like arc AC, or like if you had something like point like E or something, then this would be arc DE. Yeah, something like that. So yeah, that's what an arc is. And then an inscribed angle is like an angle that's like this. So it's on the circle, and what you do is you take 2 points that are on the circle, then you take 3 points that are on the circle, and if you connect them to form an angle like this, it's basically an angle that's on the circle. So it'll make more sense once we do a lot of questions with it. So this is a basic vocab that you need to know. So chord, like a line that's like in the circle. Secant goes through the circle, tangent 1 point on the circle. An arc is a portion of the outside of the circle, and then inscribed angle is an angle that's on the circle. Okay. So useful properties. So a circle, as you guys all know, is like really symmetrical, right? So like no matter which way you turn it, it's like it's gonna be a circle, right? So there are a lot of useful properties like this, taking advantage of the symmetry that happens. So for example, this first one, a tangent is going to be perpendicular. So a tangent has something called a point of tangency, which is basically where, you know how a tangent intersects the circle at exactly one place? Well, the point of tangency is that point where the tangent intersects the circle. Okay, so basically what this is saying is if you take a tangent line, right, and you take the center of the circle, and then you draw this to the point of tangency, then this will be a right angle with the tangent line. So this is what it's saying. And then the opposite is also true. If you have something like this, take the point of tangency, and then you draw a perpendicular line, it should also hit the center. So there's our first useful property. And our second useful property is basically with a chord, if you bisect the chord, then the chord and the radius are perpendicular. So basically, you have your center and you have a chord. Like if you find the point, the midpoint of this chord, the spot where you split the chord in half, and you draw this line between them, then this line should be perpendicular. And then the converse is also true. So if you take any chord and then you like bisect it, and then you put a perpendicular line down that way, then it should go through the center. So interesting properties there. And then on this side, we have the measure of an inscribed angle is half the measure of the intercepted arc. So this is one of the most important properties of circles and angles that you'll like ever see, because they use this a lot in questions. So basically what this is it's saying that the measure of this is half the measure of the arc that's created between these two. And this might seem a little confusing, but basically the measure of an arc, because you might be thinking like, wow, the arc is like just like a point on the circle. It should be like a length, not like a degree number, right? But basically what it's saying is if you take the center and you connect it to this like this, right? This arc measure is just a fancy way of saying this angle measure. So what it's saying is that this is half of this angle measure, which is the arc length. So I guess I can label it. Okay, so we can prove one of the easier cases in like this, and it's pretty easy. So what we have here is we have a diameter of a circle, and then we can draw like these points, right? And basically what we're trying to prove is we're trying to prove that A is half of D. So in order to prove our like thing property up here. So basically all we need to do here is we notice that D is the same thing as C, because like the angle measure of D is basically just C. That's the definition of the angle measure of an arc. And then what's C? Well, C is A plus E because it's remember, it's the outside angle. So if you didn't notice it, it's this triangle over here. And then this is the outside angle. Right? So it's like that. So okay, I probably need to redraw everything. So C equals D, and basically C equals A plus E, right? But what we have to notice here is A equals E because WY equals XY because they're both radii of the same circle. Because a circle's radius is the same throughout the circle. That's like pretty obvious, right? Hopefully. So since these two are the same, this is an isosceles triangle, which means that this angle and this angle are the same, which means A equals E. Well, what if A equals E? We can substitute this E for A. So E equals A. So C equals 2A. And since C equals D, we have D equals 2A. And what's A? So A is 1/2 D, which is what we want. Okay. Nice. Basically, this is our proof for this. You can also prove like generally not using a diameter, but I'm not going to do that here because it's a little complicated. So does anyone have any questions on how I proved that? No? Okay. So we have two more properties left. So first, any angle in a semicircle will be always a right angle. So the semicircle part is a little confusing. So the way I like to think of it as, okay, so we have a circle there, and then let's draw a diameter. Okay, so if you have any like angle in this diameter, like this angle, or like if you had like, okay, let me use a different color. Or like if you had this angle, or even if you had like this angle, these three angles that you make, these are all 90 degrees. So that's what they mean by inscribed in a semicircle. And you can figure this out because can anyone tell me the measure of this arc over here? This arc?
Oh, that's 180.
Yeah, it's 180 degrees, right? And what does this formula tell us about this angle? Any of the angles?
It's half of the center angle thing.
Yeah, good job. So all of these angles are half of these angles are half of 180 degrees, which is 90 degrees, which is a right angle, right? So all of these are right angles. This is a special case of this, but it's useful nonetheless. So finally, if you have arcs that are intercepted by congruent chords, the are congruent. So like this is just a fancy way of saying like if you have a circle and then you have two arcs like this, no, not two arcs, like if you have two chords that are like this and this, and then you know that the chords are the same length, well, then you also know that these arcs have the, like, you know that these arcs have the same angle measure and also the same length. So if you look at this, this should be pretty intuitive, but yeah. These arcs are congruent. These two chords are the same. Does anyone have any questions? Okay. So circles have a lot of useful properties. So I advise you learn like all of these like one time, and then like you can use them forever. So what these examples are trying to help us do is help us like prove some like equations that are related to angles and circles and stuff. So I'll just show you how to do the examples, and then later I will have some practice questions for you guys to do. So here it's, what is the relationship between angle measure A and arc measure B? Okay. So while these two don't seem related, they actually are. So let's just draw a line through this. Okay. So let's use green. So this angle measure over here, and okay, so since this line goes through the center and it intersects at the point of tangency, can anyone tell me what this angle is?
90.
Yeah, right. So if you draw like a diameter, like a radius, like through the point of tangency of this line, it'll always make a 90-degree angle. So this is 90 degrees, which means this side is 90 degrees, but I didn't want to draw it like that because it'd like block out the A. But so this line, this angle is now 90 minus A. Okay, so since this is 90 minus A, then this arc angle. This arc angle is now twice of that, right? So this arc angle is 180 minus 2A, right? Is everyone following me here? Because this is an inscribed angle and the arc length is twice of the inscribed angle. So now we move on. So this, I need a different color. This orange thing, orange arc. What is the length of that? Like the angle?
180.
Yeah, good job. So this is 180 because it's like half of the circle, right? So basically, so this is 180. So this angle measure plus this angle measure is 180. So B plus this is 180. So these two cancel out. So B minus 2A equals 0, or B equals 2A. So this angle is twice of this. Or if you want to write it another way, then we have A equals 1/2 B. Or this angle measure is half of this arc length. So this is pretty useful in a lot of questions. So, and it's like not as intuitive as the other ones. So I would recommend memorizing this one. All right, so next, secants. So what is the relationship between this A, B, and C? Okay, this one is just a little bit harder, but basically what we need to do here is we need to draw this line. Okay, so once we've drawn this line, we can figure out immediately that this measure, can anyone tell me what this angle measure is? In terms of like any of these?
It is half of C.
Yeah, good job. So this angle measure is C divided by 2 because it's the inscribed angle that faces this arc of C. And also like often like the diagrams that they draw will be very ambiguous. So like C, like it's not clear whether it means this arc or like this arc. Generally, they place the letter in the middle of the arc. So it would make the most sense for C to be this arc, and B will be this arc. So yeah, just something to keep in mind. And then the next thing we need is this. So can anyone tell me what this angle measure is? Remember guys, try and like, if you see like an inscribed angle, you should immediately look for the arc that it faces, right? So in this case, which arc does it face?
B over 2?
Yeah, correct. So this is B over 2 because this faces this arc B. So it was a little hard to see there, but it's B over 2. So the property that we'll use next is we need to see that in this different color. In this triangle thing, we have this C over 2 is the outside angle, which means that C over 2 equals A plus B over 2. Okay, well, it says the relationship between A and B and C. So let's just put A on one side. C over 2 minus B over 2. And then this sort of looks a little ugly, so I guess I could just back it out to 1/2. So A equals 1/2 C minus B. And then in case you're wondering, the reason why we're doing this now is because in middle school, you guys will come across a class that's called like geometry. I don't know if you guys have heard of it yet, but this is like half of the stuff that they teach in like geometry. So like you guys will be well prepared for that. Oh, someone else is here. Hello. Okay. So secant and tangent. So remember, a tangent is like a secant that only goes through like one point on the circle, right? So basically we can almost do exactly the same thing that we did before. So let's just say that
对它味道。
here, let me, okay, yeah, there we go. So let's just say that this is the point of tangency. We just intersect at the point of tangency. And then what we can do from there is we can do much the same thing. So can anyone tell me what this angle length is? Well, you guys can use example 1 for this. It has a lot to do with this.
C over 2? Half of C.
Yeah, correct. So it's C over 2 because remember, if you have something that looks like this, tangent, like with a line thing, then this is half of this arc length. So it's C over 2. And then can anyone tell me what this is?
B over 2.
B over
Yeah.
2.
Okay, it's good that you guys are seeing these a lot faster because it's a lot easier to do these questions when you guys like see them right away. So yes, this is B over 2 because this intersects it right here and right here, which is arc B. Okay. B over 2. And then we can use the same formula over here where we have this as the triangle and then this as the exterior angle. So A plus B over 2 equals C over 2. Well, that's just the same thing up here. So A equals 1/2 C minus B. I should clean that up a little bit. Yeah, so we just proved all 3 of these properties. Okay. More properties. Let's go. So intersecting chords this time. So basically we need to figure out the relationship between like A, B, and C like before, right? So one interesting thing that we can use to help us here is we can see the relationships between different arcs. Like for example, if we connected some of these like this. Yes. So I think here one of the most important ones to connect is this. Yeah. So if we connected this over here, can anyone tell me what this arc is? It's a little hard to see.
Half of A.
Yeah, correct.
Yeah.
It's A over 2 because this angle faces this arc over here. And then how about this angle?
B over 2.
Yeah, correct. This is B over 2, right? Because it faces this arc. And can anyone tell me which equation we're going to use to like relate them?
B over 2 plus A over 2 equals C.
Yes, correct. Good job. Yeah.
What
So
did I miss?
it's this plus this equals this, right? Oh,
What
wait.
did Simon miss? What did I miss?
Oh, you miss like some vocab and stuff. If you have like no idea what I'm talking about with this, I'll suggest you go back and watch the lesson recording after I'm done talking though. So the most important things we've been going over are just like proving different things like inequalities here. No, equalities, like what is it called again? Properties, yeah. So this is just a different way of writing this equation. It looks a lot nicer. So yes. Now we have parallel lines. So these parallel lines, what we're trying to prove here is that like the similarities between A and B, let's just say. I don't want to spoil the answer yet, but let's just draw this line. And this one is A over 2. It faces this arc. I'm not going to ask you guys for those ones because I'm sure you guys have already gotten this down by now. And this is B over 2 because it faces this. And can anyone tell me just from looking at this picture what's like how to relate these two angles?
A equals B.
And how do you know that?
Because since these are parallel, then these two are equal. So A over 2 equals B over 2.
Okay, yeah, that was a little vague, but yes. Yeah. So here. So an easier way to see this is if I drew this in a different mix in this. Okay. So what do we know about parallel arcs? So it's that this angle equals this angle equals this angle equals this angle, right? Because they correspond to each other. And then furthermore, this angle equals this angle equals this angle equals this angle, right? So so from this we know that A over 2 equals B over 2. Well, A just equals B then, right? Obviously. So we just prove that A equals B. So if you have parallel lines that go through a circle, that means that the arcs that the circles are with are like the arcs that the parallel lines make are equal. Okay, so example 6, cyclic quadrilaterals. So I think last time we went over like kites and like rectangles and stuff. So
Well, I've done this problem before. It's 180.
So cyclic quadrilaterals are like special quadrilaterals. Like a square is a cyclic quadrilateral in that it can be inscribed in a circle, which means you can draw a circle such that the circle hits all 4 points. Because think about it like this. Every single triangle, right? It doesn't matter like how weird the triangle is. Every single triangle is going to have a circle that goes through all 3 of its points called the circumcircle, right? I don't know if you guys have learned this yet. But basically, you can draw any circle with this. But like, let's say you have like a really short side like this. This is like, you can draw a circle. Like you can draw like a weird oval looking thing that hits all 4 corners, but you can't draw a circle that hits all 4 corners. So normally like irregular quadrilaterals are sort of like that, but cyclic quadrilaterals are different in that they can be inscribed in a circle. You see the circle touches all 4 points. Okay. So basically, we're looking for the opposite angle measures. And like, if you guys have like taken the NWEA test before for math, like this question
Is this related to triangles?
Huh?
Just related to triangles?
Not really that much. Like you can like prove this using triangles, but like there's an easier way to do it using inscribed arcs. But that's not a bad idea though. So basically like D will have like this question where like we ask you to prove this thing in like NWEA. So like if you guys listen, pay attention here, like it could give you like a couple free points for the NWEA. Okay, a different color there. Okay, so how we prove this is angle A, right? So this green arc, the line sort of like shaded in a little. So this is let's just call this arc capital A. Okay, so capital A is twice of angle A. right? So how about this? Use a different color. Okay, so let's just call this B. What's B's relation to this lowercase b up here?
2b.
Yeah, capital B is twice of the little one, right? So if we add these up, so because we can do that.
You get 2a plus, oh yeah, and then the entire 3 is 360 degrees.
Yeah, so what's a plus b? A plus b is a whole circle, and the whole circle is 360 degrees, obviously, right? So 360 degrees. So we can divide by 2 on both sides for this outside equation over here. So 180 equals a plus b. Okay, so we've proved it. So a plus b is 180 degrees. And this is true for the other pair as well, because we didn't specify which pair we would use. So this angle plus this angle also equals 180. Okay. So we've proved all three of those. And now it's time to move on to some practice questions. So basically, what they're asking for you to do is find like x, like find x. And then send your answers to me in the chat when you guys are done.
I can't really do the problem since I have like no idea.
Oh, let's see. That is kind of a problem. How about like you try like as I start explaining the questions, you can maybe understand a little bit more. And then after this class, you can go back and review the videos.
Okay.
Okay. Sam, I would double check your answers. I think here, it'd be better if I just highlighted what you guys outside or what side you guys are supposed to be. So X here, you're trying to find this. Like this. This. Yeah, that should make it more clear what you're trying to.
Oh, okay, I see.
Yeah, so you guys are trying to find the angle measure of that. And remember, the angle measure of an arc is like, oh, that's the same thing as this. This is x too. If that helps. Okay. 1 point. Whoever's name is okay, and you're very close. I'm not quite though. Kevin. I would like double check your answer there because X definitely doesn't look like it's 15 degrees to me. Okay, I guess I can start explaining now. Okay, so okay, yeah, so as I explain, you guys can like keep on sending me answers, I guess, in case like you guys are still working on a question. So here, question 5.030. So we're trying to find X. So this is a multi-step question. So can anyone tell me what this is?
35.
Yeah, correct. This is 35. Because if you look at this, this is an isosceles triangle because these two are the same. You can see like there's an isosceles triangle clearly. If you look at it like this, right? So it's an isosceles triangle. So this is 35 degrees. Let me change that. Yeah, 35 degrees. And then now this plus this is 35 degrees. So this is 110 degrees, right? Okay, so now we know that this is 110 degrees. So what do you think this big arc from here? Let's make a drawing a little oranger. This orange arc. What do you think the measure of this thing, this arc is?
Uh, 220.
Yes, it's 220 because it's twice of this thing over here. If you have forgotten, it's this first one over here, where like A is like half of, yeah, A is half of B, which means that B is twice of A. So that's, yeah, click. Okay, yeah. So that's what we're trying to use here. So this is 220, and then that's the orange one, and then we're not done yet because X is not this. X is not the orange thing. It's like this blue thing. We got sort of covered, but it's this blue thing. Which means we still need to know our battle plan. I don't know how else to put it, but like our plan is we need to find this red thing, like this arc,
Just
and we take the orange arc
70.
minus, yes.
isn't that
So
just 70?
yes,
Because
this 70. And then this arc is just this arc minus the orange one minus the blue one is okay, blue is orange minus red. And the orange is 220 minus the red is 70 equals 150. I can't write today. So this is 150 degrees. Does anyone have any questions? Okay. So moving on to this one. So this question is a little harder. So what it's asking us for is X. So first we need to figure out this. Can anyone tell me what this angle is based on like the triangle?
that's 50.
50.
Yeah, 50. So can anyone tell me what this angle is? The measure of this arc?
100.
Yes, correct. That's 100. So this plus, so 100 plus 160 plus X is 360, right?
Yeah.
Because it's a whole circle. So 100 plus 160 plus X equals 360. So this is 260, 360 minus 260 is 100. So it's 100 degrees. And there's actually a different way you can do this question, although it's a little bit more complicated, is if you say that this is 50, I think, Yeah, so basically what you can do is you can figure out that if this is 95, right? Then this red arc over here is gonna be 190. Wait. Yeah, yeah, 190 is 190. Which means that 190 minus 100 is 30, this is 30 degrees. And we know that this minus this divided by 2 is 35, right? So x minus 30 divided by 2 equals 35. Wait, no, times 2. Yeah, no, divided by 2. Yeah, that's correct. So x minus 30 equals 70, so x equals 100. Yeah, so this is a different way. If you found this way, then you get bonus points, I guess. But this was the easier way to do this question. Okay. So 5.230. Okay. So this one we saw using the second method. So first, can anyone tell me what the measure of this red thing is? This red arc?
That is
30, I think.
Yes, correct. It's 30.
oh yeah,
Because-
I have absolutely no idea.
So basically, the reason why I know it's 30 is that this red thing, this red arc, plus 80 plus
Oh
100.
yeah, since wait, so does the entire like the angles of all the arcs add together equal to 360?
Yeah, so like if you think about it, a circle is just a full angle, right? You go back to itself, right? So it's a 360. So the measure of the whole entire, like the sum of the arcs of the whole entire circle is 360. So this plus this plus this plus this is 360, which means that this is 30 degrees. We're not done yet though. We still need to find x. And x is 100 minus 30 divided by 2. I think it should be like I'm pretty sure this is the formula that's used to solve this question. And basically what we have here is 70 over 2, which is 35. So our answer here is 35 degrees. Oh, you can write it down here. Okay, so sorry, I was ending after it. Okay, so it's this question next. So this question is a little hard, though in my opinion, it's not the worst question ever. So let's get started. Okay, so this angle over here, can anyone tell me what this is?
that is
That is
160.
Good job, 160. Because this angle is inscribed and it's facing the arc. So this is twice of 80. So then if you go back and the annotations will look really ugly, but if you go back and you see example 4 here of these like, oh, I can't point. Like it says like the intersecting chords up here. We know, I think it's like the average of A and B is C. So A plus B divided by 2 is C. I think that's what we got. So we have 30 plus 160 divided by 2 is this, x. So equals 95. So x is 95 degrees. All right. So you can solve a lot of questions using these like the properties that I showed you before. Does anyone have any questions on how I solved any of these?
No.
All right. Okay, we have 6 more questions. Hooray. So I'll give you guys a couple minutes to do these ones.
E. 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 What? E. E.
I didn't stop.
Sam, for 5.430, you're really close to the answer. I think you made like a math mistake or something, like algebra mistake. So whoever's name is OKN, your answer for 5.530 is correct, I think. Yeah. Mm. 'Kevin, your answer for 5.530 is also correct. Sam, your answer for question 5.430 is correct. No, Simon, I don't think so. Kevin, your answer for question 5.430 is incorrect. You're close though.
The answer for is the answer 400.
I don't think the answer is 420.
69420.
I think you're getting further away. Kevin, I think your answer is correct for 5.432. All right, I'll start explaining the questions now. Okay, so this question actually doesn't have anything to do with the cyclic triangle. Just like forget that these two lines exist for now. So basically, this plus this is 135. So the other side, which is this. Okay, well, you could do that. Well, the other side, which is this, is 360 minus 135. So this is 225 over here. And then x is just half of this, half of 225. So x is 112.5 degrees. And then the other way you could do this is you can use this to find this angle measure, which is 135. And then this plus 100, wait. No, this is 135 over 2. Yeah, this is 135 over 2. And then x plus 135 over 2 is 180. So you could also do it that way. Okay, there we go. So 5.530. Okay, so this question, a lot of people got this, so that's good. So since this is an isosceles triangle, we know this and this is 140, so this is 40 degrees. And we all know that this is 40 degrees equals this minus this over 2. So 80 equals 120 minus x. And then x equals 120 minus 80 equals 40. So x is 40 degrees. All right, moving on. Here we have here, so we have these two are the same, which is very important in this question. So we have to connect these two. Okay, so I don't know if you guys have learned this yet, but basically we have to learn that these two angles are the same, basically. Well, like I mean, you don't really have to know that, but like it's still pretty important in the question. So basically what we have to know is this angle over here is 70 degrees. Pretty sure it's 70 degrees. And then which is half of 140. And then if you split this in half, this is going to be 35 degrees. Okay, so that's half of it done. And now we need to find this angle. What's this angle? Well, this angle is the same thing as this angle, right? Which is this is 140. So 360 minus 140 is 220, which means that each of these is 110. 110 to 110. Which means x plus 110 plus 35.
Interesting.
So x is 35. And our answer to this question is 35. All right, nice. Moving on. So here, this question is actually really hard. So basically, the center is there, by the way. The dot is there, although it might not show up very well. First you need to realize that this is isosceles because these two are the same because they're both radii of the same circle. So this is also 63. And then what's this angle? So this angle is 54. So this is 54 degrees. And then this is the angle measure of this arc. So this arc length is 54. And since these two are parallel lines, they go through the arcs that they make are the same. So this one is also 54 degrees. Okay, which means that this is 54 degrees. Now that we know that, we have to know that since this is tangent, or like the idea is that it's tangent, so then this has to be 90 degrees. And since this is 54, this must be 36. And then 36, 63, and x, if you add all these together, this must equal 180. So x equals 81. So x is 81 degrees. Okay. So that's question 5.730. And then question 5.830 is also pretty nice. So basically, what we're going to do here is we have to draw a bunch of lines. Okay. So these lines are all 90 degrees because they all intersect tangents. Okay, so the nice thing that we can do here is if we connect this, this is 20 degrees, which means that this is 70 degrees, and this is also 70 degrees, which means that this whole thing over here is 140 degrees. Now, this pink thing is 140 degrees. Okay, how can we use this information? So if we go back to our original lines.
Are these three equal?
Which ones?
Wait, are these? Wait, those are not equal. Never mind. Wait.
Are we talking about like these things?
Yeah.
Oh, these here are right out of, if you're talking about their lengths, then they're equal, yeah, because they're right out of the same circle.
Ah, okay. Fifths.
Okay, so basically the neat thing to know here, let's say this is angle 1, okay? This is angle 1. So then what's this angle? This angle is the same thing because it's like you reflected the angle over this. Like you guys will learn this a bit later, but basically this is just a congruent triangles because the hypotenuses are the same, like these two lengths are the same, so they're congruent triangles. So that this angle is also 1. And similarly, if this angle is 2, this angle is also 2. So 140 equals angle 1 plus angle 1 plus angle 2 plus angle 2. And what do we want to know? We want to know x.
Oh, but x is angle 1 plus angle 2.
So what's 140?
Yeah.
So x, 140 is twice of angle 1 times angle 2, plus angle 2. Equals 2 times x. So 140 is 2x, which means x is 70. Okay, so that was pretty neat for this question. And next we have our last question, which is also again pretty hard. Okay, let's take a look. So the trick for this question is to like be generous with your colors, I guess, if you brought like highlighters or whatever. So this green is 160. Because it's twice of 80 degrees, because 80 degrees is this. And then
That
what's
means
100?
the rest. That means the rest, like the rest of the circle, would be 200.
Very observant of you. But basically, this red thing overlaps with the green a little bit. But what's the red thing? Remember, this inscribed angle over here has measured 125. This is twice of 125, right? Because like just because the angle's a little like small doesn't mean that it's like not the property doesn't exist. So this is 125, this red. Okay. So basically, what happens if we add the red and the green?
You get
Think
full
about this.
circle.
You add the red and the green. Well, you
it
get the
overlaps.
whole circle, but what do you count twice? What do you count twice?
Oh, okay. So the
The X area.
the entire thing, the entire measure of the circle is 360. So then whatever overlaps It's
yeah, you're
it's
getting it.
X.
You
Because
can't add twice, because you have to add it back in again, right? So this is 360 plus X is the red plus the green. We know that the red is 125, and we know that the green is 160. Wait, no, the red is 250. Never mind. So the red is 250. All right, I need to multiply that by 2. Yeah, so the red is 250 plus 160 equals 360 plus X, right? So then X should equal 50. Oop, I wrote that a little incorrect. Yeah, X equals 50. All right. So this question was actually pretty hard, so like don't feel bad if you didn't get it, but yeah. That's just we over counted X, so we had to add it back in again. So yeah. All right. So does anyone have any questions?
No.
All right, so that is it for today, and thank you guys for coming. So
Okay, bye.
next week our meeting will be in the library, so don't forget about it.
Ooh,
Okay.
okay. Bye.
And then
See ya.
we'll mock countdown round. So